You know how sometimes you look at your watch or phone, just automatically checking the time?
Mm-hmm.
Imagine stepping back over 1,500 years to the city of Pataliputra in 499 CE.
Wow.
The air is probably still cool before dawn, and a young scholar named Aryabhata is awake, maybe watching the last of the stars.
Yeah.
All around him, the rhythms of life are unfolding. Water clocks slowly dripping, farmers stirring as the sky lightens. Time, then as now, is this constant presence. But how do you actually grasp it?
Right. How do you measure it? Systematize it?
Exactly. Aryabhata's quest to do just that, laid out in his ancient texts. Well, it still resonates in the GPS guiding you to a new cafe, or the calculations sending rockets beyond our atmosphere.
What's truly captivating is this fundamental human drive, isn't it? To find order in the flow of time. Long before Aryabhata, civilizations were tracking the sun, the moon, the seasons.
Sure.
But he wasn't just observing. He was building a system, a language of time itself.
Exactly. And the foundation of that language, his initial understanding, that's what we're diving into today.
Okay.
We're exploring the first 4 verses of his work. The Kālakriyāpāda, picture it as the very first page of his cosmic pocket watch manual, maybe.
Ha! I like that. Cosmic pocket watch.
If you recall our past deep dives, episode 19 hinted at Aryabhata's brilliance. Episode 18 explored the math behind fair distribution, which, links to agricultural cycles.
Right. Timing is crucial there.
Episode 13 showed us the revolutionary power of decimals that underpin all these calculations. And even episode 17's look at math puzzles gives us a sense of the intellectual energy of the era. All of that sets the stage for understanding what we're about to uncover.
Mm-hmm.
Our mission today is to trace how Aryabhata moved from something as personal as, well, a breath,
Yeah.
to the grand sweep of cosmic time.
To truly appreciate Aryabhata's achievement, you have to picture the world he inhabited. 499 CE in Pataliputra. This was during the Gupta Golden Age in India.
Right, a really vibrant time.
Oh, absolutely. This was a period of incredible flourishing. Art, science, mathematics were all advancing rapidly. Think of the bustling silk trade routes connecting east and west.
Huge economic driver.
The renowned university at Nalanda, attracting scholars from across the continent, and Ujjain emerging as a vital center for astronomical study.
So it wasn't just theoretical.
No, not at all. This wasn't just an ivory tower of intellect. There were very real practical needs driving the quest for accurate timekeeping.
Absolutely. Remember our discussion in episode 18 about Gopal and his crops?
Yeah, I do.
Planting and harvesting are utterly dependent on aligning with the seasons. You mess that up and rail well.
Exactly. Then you have the rich tapestry of rituals and religious observances, many of which followed incredibly precise timings dictated by celestial events.
Timing was everything for rituals.
And of course, the burgeoning field of astronomy itself needed a consistent and reliable framework for charting the movements of the stars and planets.
Which brings us back to Aryabhata. What's fascinating here is his focus. He's just 23 years old, right?
Yeah, incredibly young. And he wasn't lost in abstract philosophical debates about the nature of time itself.
No deep metaphysics here. Not yet, anyway.
Instead, he was deeply engaged with the observable world around him. The predictable rhythm of sunrise and sunset, the cyclical phases of the moon, the annual journey of the constellations. He was a meticulous observer, first and foremost, searching for the underlying mathematical order in these natural cycles.
That's right. His aim wasn't some lofty philosophical treatise, but something much more practical. A working system.
A tool.
Yeah, a tool. He wanted to create a framework that could be used by astronomers, priests, and even farmers, a system for creating accurate calendars, for determining the auspicious times for rituals, and for making precise astronomical predictions.
So it had to work in the real world.
Exactly. So with that vibrant context in mind, let's wind back to the very first gears of this cosmic pocket watch, the initial verses of the Kālakriyāpāda.
Okay, let's begin by unpacking the very first verse. It's really the bedrock upon which his entire system of time measurement is built.
Right. Here's the translation of that foundational verse. A year is 12 months, that month is 30 days. A day is 60 nuts, and a knot is 60 vināḍikās. Now, thinking of our cosmic pocket watch analogy, this verse lays out the primary gears, the main divisions of time. The largest gear, the most encompassing unit, is the year, which he divides into 12 months. Pretty standard stuff so far, maybe.
Well, yes and no. The idea of a year divided into months was common, of course, but what's significant here is the move towards a standardized, mathematically convenient system, defining a month as precisely 30 days.
even though lunar months aren't exactly 30 days.
Right. It's a slight simplification of the actual lunar cycle, but it provided a consistent unit for calculation. It speaks to Aryabhata's desire for a coherent mathematical framework, even if it meant a little bit of idealization.
Exactly. Makes the math cleaner. Then we step down to the next level, the day. Aryabhata divides a single day into 60 nuts.
60, that number keeps popping up.
It does. Now, a nutch is a unit of time, roughly equivalent to, 24 minutes in our modern measurements?
That's right, about 24 minutes. As we discussed back in episode 15 with shadow clocks, these nushes would have provided practical segments for organizing daily life and tracking time within the day. Think of it as larger chunks of time within a day.
Okay, manageable chunks, like half-hour slots almost, but not quite.
Precisely. And then within each nacha, Aryabhata introduces another division. According to this first verse, each nash is further subdivided into 60 vinachas.
60 again.
60 again. This means a vinache is approximately 24 seconds in our modern understanding.
Wow, down to 24 seconds. That's pretty granular for 499 CE.
It is. You can see this elegant base 60 hierarchical structure emerging, moving from the grand scale of a year right down to these much smaller, more granular units.
And the beauty of this precise system is its inherent practicality, isn't it?
Absolutely.
Imagine trying to create a consistent calendar that everyone could follow, or attempting to predict the exact timing of celestial events without such clearly defined units.
It would be chaotic.
Yeah. These divisions allowed for a level of accuracy that was absolutely crucial for Gupta-era society, influencing everything from the precise scheduling of agricultural activities, as we mentioned, to the minute-by-minute requirements of religious ceremonies and the creation of those vital star charts used for navigation and prediction.
Indeed. This single verse provides a fundamental architecture for organizing time. Now, the second verse, well, it takes this understanding a profound step further.
It really does.
It connects the seemingly abstract concept of time to something deeply personal and universally experienced.
Absolutely. Here's the translation of the second verse. 60 long syllables are a sidereal vinaka, or 6 breaths. Thus, time is divided. So too is the field space from the revolution.
Okay, 6 breaths.
6 breaths. Now, this is where the connection between the human and the cosmic becomes truly striking.
It does. Here, Aryabhata introduces a truly fundamental, almost primal unit of time, the human breath. He states that 60 long syllables, which is apparently the time it takes to recite them, or, more simply, 6 breaths, are equivalent to 1 sidereal vinoka.
Which we just said was about 24 seconds.
Exactly. So 6 breaths equals roughly 24 seconds. This is an extraordinary link between the individual, the human scale of experience, and the vast impersonal scale of the cosmos.
It's such a tangible, almost visceral connection, isn't it? Something as basic and essential as our own breath becomes a measure of time, a fundamental tick of the cosmic clock. And through that, it's inherently linked to the grand movements of the heavens. He then goes on to connect this to the Earth's rotation.
Right.
He essentially states that with every breath, the Earth rotates by 1 kala, which is an arc minute. We explored the concept of interconnected cycles back in episode 13, remember?
I do, and this is another powerful illustration of Aryabhata recognizing these fundamental rhythms.
Yep.
So in essence, according to Aryabhata, with every 6 breaths you take, the Earth completes 1 sidereal vinoka of its rotation. That's 1/60th of a nut, and also equivalent to approximately 24 seconds. Over the course of a sidereal day, which, importantly, is the time it takes for a distant star to return to the exact same position in the sky.
Not quite the same as a solar day.
Not quite, a little shorter. During that sidereal day, there are 21,600 breaths.
21,600, that sounds familiar.
It should. That number, 21,600, is significant because it relates directly to the 360 degrees of the Earth's rotation.
Ah, right. 360 degrees times 60 arc minutes per degree.
Is 21,600 arc minutes, or kalas, and he's saying 1 kala corresponds to 1 breath.
So breath equals rotation equals a unit of the sky.
Wow, it's incredibly elegant.
And what's so profound here is that he explicitly draws a parallel between the division of time and the division of space. He states that just as time is divided into these precise units, so too is the field space from the revolution.
Right. The 360 degrees of the celestial sphere, the apparent dome of stars, mirrors the 360 degrees of the Earth's rotation, and both are intimately linked back to this fundamental unit of the breath.
Mind blown.
It reveals a deep and insightful understanding of the interconnectedness of the cosmos. And while we can see echoes of the sexagesimal system, the base 60 mathematics prevalent in ancient Babylonian cultures.
Yeah, that 60 and 360 feels very Babylonian.
It does, but the unique way Aryabhata integrates it with something as intrinsically human as the breath suggests a distinct Indian perspective.
I'm sure.
Perhaps a particular philosophical lens applied to this mathematical framework. It's not just abstract numbers, it's rooted in a very human experience.
It's a fascinating and potent blend, isn't it? Potentially cross-cultural mathematical ideas mixed with indigenous observation and maybe philosophy.
I think so.
And the truly astonishing thing, as we touched on right at the beginning, is that this ancient understanding, this fundamental connection between Earth's rotation and precise timekeeping, well, it continues to tick within the clock of your GPS system today.
Right. The incredibly precise measurements of Earth's rotation are absolutely fundamental to how those satellites pinpoint your location on the globe. It needs that kind of accuracy.
It's a remarkable and sort of unbroken lineage of knowledge stretching across millennia.
It really is. Now, the next two verses, 3 and 4, they move beyond these foundational units of time and delve into the more complex and dynamic realm of planetary motion.
Right. Okay, verse 3 begins to tackle the intricate relationships between the movements of different celestial bodies. Here's the translation. The revolutions of any two planets, their difference in a yuga, are their conjunctions. The sum of the sun's and moon's sidereal revolutions combined are the vināḍikās.
Okay, that's dense. Let's unpack it.
Yeah, let's try. First, this yuga concept.
Right. Aryabhata introduces the concept of a yuga, which is a very large cycle of time in Indian cosmology spanning hundreds of thousands or even millions of years, a huge time frame.
Okay, a cosmic age.
Exactly. Within this vast time frame, he's essentially saying that if you consider any two planets and calculate the difference in the number of times each of them completes a full orbit around the sun, or the Earth, depending on the specific model he was using, within that yuga.
Okay, so planet A orbits X times, planet B orbits Y times.
Right. That numerical difference, x minus y or y minus x, directly corresponds to the number of times those two planets will appear to come into conjunction.
Conjunction meaning close together in the sky.
Exactly. Very close proximity as seen from Earth during that same yuga.
Huh. It's almost like thinking about a sophisticated scheduling algorithm, maybe for musicians releasing albums or something.
Huh. Explain that.
Well, if one artist releases an album every 2 years and another every 5 years, the algorithm could predict how often their new releases will coincide, right?
Yeah, okay, I see that.
Aryabhata was doing something similar for the cosmos, predicting these celestial alignments with mathematical precision instead of computer code.
That's a wonderfully relatable analogy, and the source material actually gives us specific examples to illustrate this. For instance, it mentions that within a yuga, Mars completes approximately 2.3 million revolutions.
Wow.
While Jupiter completes around 364,000 revolutions.
Okay, big difference.
A very big difference. And the difference between these two numbers, roughly 1.9 million, represents the number of times Mars and Jupiter will be in conjunction during that immense yuga.
That's incredible calculation for the time.
Yeah.
It demonstrates a remarkably sophisticated understanding of the relative speeds and orbital periods of these planets.
It really does.
And then Aryabhata introduces this term, vināḍikās. He explains it as the sum of the sun's and moon's sidereal revolutions within that same yuga.
The sum, this time not the difference.
Right. The source provides figures of around 4.3 million sidereal revolutions for the sun and a staggering 58 million for the moon.
Whoa, the moon moves fast relative to the sun.
Totaling approximately 62 million. Now, the vināḍikās is a significant astronomical configuration in Indian tradition, often associated with specific astrological events and potential disruptions in the usual celestial order.
Right. While the precise astrological interpretation and application of the vināḍikās is complex and has evolved over time, it's highly probable that Aryabhata is laying a fundamental mathematical groundwork here.
Groundwork that could be used for what?
Well, potentially utilized to predict or understand phenomena like solar and lunar eclipses, which, as you mentioned, we touched upon in episode 15.
Okay.
However, in this particular verse, his primary focus seems to remain on establishing the mathematical relationship between these fundamental celestial cycles, the sheer number of their revolutions within this grand cosmic cycle, the yuga.
Got it. So verse 3 is all about these grand cosmic relationships, these intricate planetary dances, and the underlying mathematical principles that govern their timing and alignment.
Precisely.
Now, let's move on to the fourth verse, which introduces yet another layer of complexity to our understanding of planetary motion.
Indeed. Verse 4 states, revolutions of apogees subtracted from the planet's own revolutions are the apogee-perigee cycles. Jupiter's revolutions multiplied by signs 12 are Jupiter's years, beginning from the start of the zodiac.
Okay, apogees. This sounds like it's getting into orbits not being perfect circles.
That's exactly right. This verse delves into the nuances of planetary orbits, specifically addressing their elliptical nature, even if they didn't use that exact term then.
Right. We now know from modern astronomy that planets don't travel in perfectly circular paths, but rather in slightly elliptical ones.
Mm-hmm.
And this elliptical shape means that a planet's speed actually varies as it moves along its orbit. It travels a bit slower when it's farther away from the sun, at a point called apogee,
For this point,
and a bit faster when it's closer, at a point called perigee.
closest point.
Think of it like a pendulum swinging back and forth. It moves fastest at the bottom of its swing and slows down as it reaches the highest points.
That's a great analogy. So when Aryabhata refers to the revolutions of apogees, he's talking about the movement of that farthest point, the apogee itself, in a planet's orbit relative to the background stars. It also shifts slowly over time.
Okay, so the slow point moves.
Exactly. By mathematically subtracting the number of these apogee cycles from the total number of the planet's own revolutions within a yuga, Aryabhata is essentially calculating the cycle of this orbital pulse, this periodic variation in the planet's speed as it traverses its elliptical path.
So he's accounting for the speeding up and slowing down.
He's finding a way to mathematically describe that cycle. We discussed the general concept of orbits back in episode 14, and this verse provides a much more detailed and sophisticated understanding of their dynamics.
And again, while this might sound like abstract astronomical theory, it has very tangible, real-world applications, even today, right?
Oh, absolutely. Think about the incredibly precise calculations required to keep modern GPS satellites in their designated orbits.
Right, they're not in perfect circles either.
No. Those calculations absolutely have to take into account the slight variations in the satellite speeds due to the elliptical nature of their orbits. If they didn't, the whole system wouldn't work accurately.
So, in a remarkable way, Aryabhata was laying the foundational mathematical groundwork that underpins some of our most advanced technological systems in the 21st century.
It's quite something. And the second part of this fourth verse introduces the concept of Jupiter's years.
Jupiter's years, what's that?
Aryabhata states that if you take the number of Jupiter's revolutions within a yuga, which we mentioned is around 364,000, and multiply it by the number of zodiac signs, which is 12.
Okay, 364,000 times 12. That's a big number.
It is, around 4.4 million. But the point isn't just the big number. Each of these conceptual Jupiter's years actually corresponds to a 12-year cycle based on the apparent movement of Jupiter through the zodiac constellations as seen from Earth.
Ah, okay. Jupiter takes about 12 years to go through all the zodiac signs.
Roughly, yes. And these 12-year cycles then combine to form the larger 60-year cycle of the traditional Indian calendar.
The 60-year cycle, I've heard of that.
Exactly. And incredibly, that 60-year cycle, derived partly from this understanding of Jupiter's movement, is still in use in various parts of India even today in 2025.
It's truly astounding, isn't it? This system of timekeeping, developed over 1,500 years ago based on careful astronomical observation and mathematical reasoning, continues to influence how time is reckoned in certain cultural and religious traditions, even in our modern era.
It's a powerful testament to the accuracy and enduring utility of Aryabhata's profound insights.
Definitely.
So when we consider these first 4 verses of the Kālakriyāpāda together, we see Aryabhata meticulously constructing a comprehensive and interconnected system for understanding and measuring time, moving seamlessly from the smallest, most personal units like human breaths to the grandest, most impersonal scales of planetary revolutions and vast cosmic cycles.
And it really prompts you to reflect on your own everyday relationship with time, doesn't it?
It really does.
Think about how frequently you glance at your watch or the clock on your phone. You're essentially relying on devices that measure divisions of a day into hours, minutes, and seconds. A system that, in its foundational principles, echoes Aryabhata's division into nachis and vināḍikās.
The 60-fold division is still there in minutes and seconds.
Right. When you look at a calendar to plan your week or your year, you're engaging with a system that, in some traditions, still incorporates those ancient Jupiter cycles we just talked about.
A 60-year cycle, yeah.
And as we've discussed, even something as seemingly modern and ubiquitous as your car's GPS relies on sophisticated mathematical principles related to orbital mechanics like those apogee cycles that Aryabhata and his contemporaries were exploring centuries ago.
What's so thought-provoking is how these seemingly disparate scales of time, the subjective personal experience of breathing, the societal need for accurate calendars, and the majestic astronomical movements of planets are all elegantly interconnected within Aryabhata's comprehensive framework.
Yeah, it all fits together in his system.
Verses 1 and 2 beautifully establish this fundamental link between our most basic human experience, the breath, and the grandest cosmic rhythms. And as we've seen, these ancient insights have incredibly practical and enduring technological applications.
From breath to GPS, basically.
Yeah.
And verses 3 and 4, while venturing into the more complex and dynamic realm of planetary motion, well, they have implications that stretch from ancient astrological interpretations to the remarkably precise calculations that underpin modern space exploration. The very same fundamental principles that Aryabhata used to understand the conjunctions of planets are, okay, in a vastly more sophisticated mathematical form.
Sure, much more advanced now.
But they're used today to plan the trajectories of probes sent to Mars and the precise orbits of our communication and Earth observation satellites.
It truly underscores the enduring power and relevance of these foundational scientific insights. And as we touched on earlier, while there are certainly potential historical links to mathematical traditions from other parts of the ancient world, particularly Babylonian mathematics with its base 60 system.
That sexagesimal link seems pretty strong.
It does. But the unique way in which Aryabhata synthesized these ideas and integrated them with his own meticulous observations and his distinctive Indian philosophical outlook, well, it represents a truly significant and groundbreaking intellectual achievement within the history of Indian science.
It really does powerfully illustrate the idea that scientific progress is rarely a solitary endeavor, is it? It's more a continuous process of building upon the work of those who came before, across cultures and across the vast expanse of time.
Well said.
And to bring it back to a deeply personal level for you, our listener, I really encourage you to take a moment sometime today and try that simple exercise we mentioned earlier.
The breathing.
Yeah. Just take a pause and count 6 slow, deliberate breaths. Feel that time pass. That small span of time, that fundamental human act, is what Aryabhata, in his profound wisdom, linked to the rotation of our planet and the immense grandeur of the cosmos. About 24 seconds.
And by consciously engaging in that simple act of counting your breaths, you're creating a direct, tangible connection to a system of timekeeping that was conceived and developed over 1,500 years ago.
Yeah, it's like touching history.
It's a powerful and immediate way to appreciate the ingenuity and the enduring relevance of Aryabhata's remarkable work. Perhaps it might even inspire you to think a little differently about the seemingly mundane act of checking the time on your phone or your watch.
Absolutely. We would genuinely love to hear about your experiences if you try that breathing exercise and any other reflections you might have on this deep dive into Aryabhata's work. Please do share your thoughts and insights with us on social media. We're always eager to hear what resonated with you.
So in summary, this deep dive into the initial verses of the Kālakriyāpāda has revealed Aryabhata's extraordinary and interconnected system for measuring time.
It really is extraordinary.
A system that elegantly integrates units ranging from the most fleeting, the human breath, to the most expansive, the grand cosmic cycle, the yuga. It's a powerful testament to his intellectual brilliance that these ancient insights continue to resonate deeply and even underpin some of the most advanced technologies that we rely on in our daily lives.
And it leaves us with a truly thought-provoking question to consider long after this deep dive concludes, doesn't it?
What's that?
What are the broader philosophical implications of understanding time, not just through our subjective human experience, our feeling of time passing, but through these precise and predictable mathematical and astronomical cycles?
Right. How does this objective, cyclical view of time, as envisioned by Aryabhata, compare to our more personal and often linear perception of time's passage? Birth, life, death. That feels very linear.
Exactly. Does seeing it as cycles change how we view our place in it all? It's certainly something profound to contemplate.
Definitely something to chew on. In our next deep dive, episode 21, we'll be tackling another fascinating and practically significant aspect of Aryabhata's work,
Oh, what's next?
His ingenious solution to the long-standing historical challenge of accurately reconciling the slightly mismatched cycles of lunar months and solar years.
Ah, the calendar problem. That plagues everyone.
It does, and getting it right had crucial implications for accurately timing important events like festivals, including Diwali, for instance,
Right.
and maybe even for understanding natural phenomena like the ebb and flow of tides, further underscoring the interconnectedness and underlying harmony that he perceived within the cosmos.
Sounds fascinating.
Yeah.
So please make absolutely sure you subscribe to the deep dive so you don't miss that upcoming exploration into Aryabhata's continued brilliance.
Please do.
And if you found this journey into Aryabhata's cosmic clockwork as fascinating as we did, please take a moment to leave us a review wherever you listen to your podcasts. It really does help others discover these incredible ancient insights.
It really does.
We'd also love for you to continue the conversation online. Engage with us on social media. And for this particular episode, please use the hashtag #Kālakriyāpāda. Let us know what moment stood out to you.
And don't forget our Timekeeper Quiz question for this deep dive. According to Aryabhata's system, as outlined in these initial verses, is 24 seconds a muhurta, a vināḍikās, or a kala?
Oh, good one.
Please post your answers using the hashtag #Kālakriyāquiz. We're also especially curious to hear if you can identify any echoes or reflections of Aryabhata's mathematical thinking or his concepts of time in your own daily life. So please share your examples and insights using the hashtag #AncientTimeToday. We'll be eagerly looking out for your posts and engaging with your thoughts.
Thank you so much for joining us on this deep dive into the ticking clocks of the cosmos and the brilliant mind of Aryabhata. Until our next exploration into the depths of knowledge, keep questioning, keep learning, and keep exploring.